Question number 18. Evaporations of water can be represented by the following equation. From liquid state change to gaseous state, that means steam. Is evaporation of water an exothermic or endothermic process? It's easy. It is an endothermic process because energy is needed. Explain at atomic or molecular level. Okay. Now, in liquid state, for Form 5 students, you must be very familiar with this diagram. Water molecules are attracted together by hydrogen bond. Do you remember? By hydrogen bond. Okay. So, energy is needed to break the hydrogen bond between water molecules. Energy is needed. Therefore, it is an endothermic process. So you may put down the sentence here. Energy is needed to overcome the hydrogen bonds between water molecules. Use this diagram to help you to understand. For Form 4 students, you haven't learned what is the meaning of hydrogen bond. So you may consider intermolecular force. Actually, hydrogen bond is a particularly strong intermolecular forces or van der Waals forces between molecules. You will learn later. Okay. Hence, suggest one use of water. One use of water. It can be used as a coolant of hot engine. Okay, used as a coolant of hot engine. Next, question 19. Nitrogen and oxygen constitute about 99% of air in the atmosphere. Of course, based on your Form 2 IS, you should remember 78% is nitrogen, 21% is oxygen. Okay, when nitrogen occurs, they absorb energy. They absorb enough energy to react and form nitrogen monoxide. This is nitrogen monoxide with a triple bond formed between. Okay, write an equation for the formations of nitrogen monoxide in air. Nitrogen gas reacts with oxygen gas to form nitrogen monoxide gas. In order to balance this equation, put 2. Next, state the change in the form of energy in the above reaction. Lighting. We have electrical energy. Okay, electrical energy change to chemical energy. Therefore, form. Look at form of energy. Use your Form 1 IS knowledge from electrical energy to chemical energy. Do you understand? Comment on the relative energy change in bond breaking and bond forming process. Now, I give you a tips. Okay, it is an endothermic process. It is an endothermic process because look at this sentence. They absorb energy. Absorb energy. That means it is an endothermic process. For an endothermic process, first of all, draw its enthalpy level diagram. Enthalpy is y-axis. Reaction coordinate or reaction pathway is the x-axis. Endothermic process. Here are the enthalpy of the reactants NO and O2. Endothermic, that means pointing upwards. We have the product 2NO. Do you understand? Because in this question we need to consider the bond breaking and bond forming, so let's use the red pen to represent. Energy is needed in bond breaking. Finally, we have O becomes atom, 2N atom and 2O atom. And then energy is released during bond forming. And obviously, energy needed in bond breaking is larger than the energy released in bond forming. Therefore, the overall reaction is an endothermic reaction. So let's explain in detail. Here, let's draw the structural formula. We need to break N triple bond N. We need to break O double bond O, 1 mole of it. And then 2 moles of N triple bond O are formed. 2 moles of. So, how to answer this question? Please tell me the energy needed in breaking 1 mole of N triple bond N and 1 mole of O double bond O is larger than the energy released in forming 2 moles of N triple bond O. Do you understand? Okay, that's the answer for part C. Okay, use the enthalpy level diagram. Tell me what is really happening in the bond forming process and in the bond breaking process and in the bond forming process, and compare their relative energies. So that's all for question number 19. Let's look at question number 20. When potassium sulfate with formula K2SO4 dissolves, that means solid, dissolve in a bag of water. The bag containing the solution gets cooler and may work as a cold pack. Is the dissolution of potassium sulfate an exothermic or endothermic process? It's easy. It must be endothermic. Explain your answer at atomic or molecular level. Now again, let's look at the dissolution, the equation for the dissolution. Here, dissolve in water. Finally, can you tell me what are formed? Okay, we have mobile potassium ion, 2 moles of it, and 1 mole of sulfate ion. They are at gaseous aqueous state. Okay, so let's look at the bonding. During the reaction, energy is needed to break the ionic bond. Maybe I use a piece of paper to put down the answer. You may write down these 2 sentences first. Energy is needed to break the ionic bond between potassium ion and sulfate ion. Is that right? Besides, we need to break. Energy is also needed to break the hydrogen bond between water molecules. For Form 4 students, please consider, please try to learn water molecule, and water molecules are attracted by hydrogen bond. I will talk about this later, okay? For Form 5 students, you must be able to mention about the presence of hydrogen bonds between water molecules. And next, let's continue. Finally, after dissolution, energy is released in forming. Now it is difficult, you haven't learned before, okay? In forming the electrostatic attraction between the potassium ion and water molecules. Now I will use diagram, okay, later. And sulfate ion and water molecules. Now what does this sentence mean? After the dissolution, potassium ion, the mobile potassium ion, actually is surrounded by a lot of water molecules. Water molecule O will have a negative charge, and then surrounded actually is electrostatic attracted. A lot, we have a lot. Because attraction, electrostatic attractions are formed, energy is released. Now I repeat this by using this diagram. Energy is released in forming electrostatic attraction between potassium ion and water molecule. How about sulfate ion? Sulfate ion is negatively charged. Water molecule will use this hydrogen to surround sulfate ion. Surround actually is attracted. I draw some more water molecule. Because each atom of water molecule have partial positive charge. Again, Form 5 students, you must be familiar with this diagram. Okay, surround actually is a type of electrostatic attraction between sulfate ion and water molecules. Okay, now the reaction is endothermic. Can you tell me which one is larger? Endothermic. That is the energy needed to break the ionic bonds between potassium ion and sulfate ion should be larger than the energy released in forming the electrostatic attraction between potassium ion and water molecules and sulfate ion and water molecules. It is difficult, okay? You must go into the microscopic world and then identify the type of attractions, okay? It's difficult. You must practice many times by using diagram. Next, compare the enthalpy between the substance before and after. Now, because it is an endothermic process, that means the enthalpy of the substance after should be higher than the enthalpy of the substance before. Next, suggest one use of the cold pack. One use of the cold pack is easy. I have mentioned this before. Treating sports injuries or reducing swelling or pains. Okay, that's all. Now the last one. Question number 21. Liquid hydrogen. Liquid hydrogen can be used as fuel for launching of a space shuttle. Before liquid hydrogen is burned, it is stored in the storage tank. An oxidizer, usually liquid oxygen, is stored in another storage tank. The combustions of liquid hydrogen and the oxidizer can be represented by the following equation. It is stored in liquid form, but in the reaction, both change to gaseous form. Launching of space shuttle into the space. States the direction of heat transfer between the system and the surroundings. Now, because this reaction is an exothermic reaction, so heat is transferred from the system to the surroundings. Can you follow? Heat is transferred from the system to the surrounding, as the reaction is an exothermic reaction. State which bond is broken during the combustion. It is easy. State which, it is easy. Maybe I give you to finish all by yourself. And if you have problem, you may come and ask me. That's all for this chapter.